Here we have another question. In this question we have an inclined surface. And we have a resultant force which is unknown. And we have F3 force unknown. And we have F1 and F2 are already given. So we need to calculate the value of resultant and the value of the force F3. Step number one, when we have an inclined surface, it is easy to consider the inclined surface to be the x-axis as follows. So accept this to be the x-axis, and then this, of course, the one that is perpendicular to this inclined surface will be the y-axis. This will make our life way easier. So as we have done before, what we need to do is to resolve the forces into x and y direction. And of course the x direction in this case will be parallel to the x. So for f2x, that will be the f2x, and this will be the f2y. And for f1x, this will be f1x, and this will be f1y. So this will be f2x, this is f2y, and this is f1y, this is f1x. So of course f3 will be in the y direction, doesn't have any component, and same thing goes for the r, or the resultant is also aligned with the x-axis. We need to make a conclusion at this point to be able to solve this problem. So step number one is that we know the rules of resultant is the sum of all forces in the x direction should be equal to the x component of the resultant, and sum of all forces in y direction should be equal to the y component of the resultant. Of course, we are not in the business of calculating the resultant like r is equal to rx squared plus ry squared, but we'll explore this as we go. So we care about the first two for now. Now if we take a closer look to what we have here, you will notice that the resultant is in the x direction, so meaning that the x component for the resultant is also lying in the x direction. So that means the r is equal to also rx, because this is the x-axis. What about the ry? If the r is same as rx, it means there is no ry. So the value for ry is equal to 0. So we take this conclusion and add it to the equation here. We say the ry is equal to 0. And for the forces in the x direction, sum of all forces in the x direction is equal to the, of course, the x component of resultant, and it is equal to the resultant. This is a very important conclusion, because to be able to solve this problem we need to make these two conclusions. So that will be conclusion number one, and this will be conclusion number two. So once we get these two conclusions, then we have the plan to start to work on our example. And as we have learned before, well, now that we have the plan as how to solve this problem, we need to start to apply these rules to be able to get the values of r and f3. So again, if you remember from the previous example, we were looking to our options, either to start with the sum of all forces in the x direction equal to 0, or sum of all forces in y direction equal to 0, and see which one will give us an equation that have only one unknown. And in this case, if you look at the sum of all forces in x direction, that will give us an equation that has only the resultant to be unknown. So and even if we do the sum of all forces in y direction equal to 0, we'll get also one unknown. So both of them will be valid. You can start with each one with whichever you think is more appropriate. Both of them will be fine. So let's do that. So we'll do the sum of all forces. Sum of all forces in x direction is equal to r. We'll use this one. So for x we have plus f2x, because this is in the positive direction, and then we have minus f1x, because this is in the negative direction, and then we have the resultant, and the resultant, of course, this is equal to the resultant, and keep in mind the resultant is going in the positive direction. So I would assume, I would like you also to do that, but plus r, because sometimes if this is reversed in the other direction, you must put minus r. So once we have this equation, then it will be easy to work on, because we'll calculate the values of f2x, and f2x will be equal to, f2 is equal to 20 kilonewton, and the angle here is 70 also, so it will be 20 cosine 70 degrees minus an f1x is equal to, f1 is equal to 4, and of course this angle is 50 and this is 50, so it will be cosine 50 degrees is equal to plus r, which is unknown. So now we can get the values for these two, which is equal to 6.84 minus 3.06 is equal to r, and then r is equal to 3.78 pounds. So we got the value of r with this equation. Now we can move to the sum of all forces in the y direction is equal to ry, which is equal to 0. So we'll do that. Sum of all forces in y direction is equal to 0, and that will be plus f3. This is the unknown left for us, and we have f2y is downward, so it is minus f2y is equal to 20 sine 70 degrees, and for f1 y, again it is negative and downward, so it will be f1 is 4 sine 50 degrees is equal to 0. So this is the equation that we have here, and for 20 sine 70 is equal to, so this is plus f3 is f3 minus, this is 18.79, and 4 sine 50 is equal to 2.57 is equal to 0. So now f3 is equal to 21.36 pound, and that is the final answer for the question. So we have the value for r and value for f3 calculated.